In this presentation, you will learn how to work with an MLX200 robot. We will go through the PLC settings, HMI settings, and a quick overview of the hardware setup procedure and cable connections. If this is your first time using an MLX200 system, you can use this presentation as a startup guide and follow along at your own pace. By the end of the session, the MLX200 controlled robot should be communicating with the PLC and moving in manual mode. This Mind Flash session is intended as a quick start guide for robots using the MLX200 control system. If you already have your equipment, this presentation can be used alongside with your PC and robot hardware to guide you through starting up a MLX200 controlled robot. If you do not have hardware, this presentation will give you an overview or refresher of the steps to begin working with an MLX200 robot. The target audience for MLX200 are users who are already familiar with Rockwell software. This includes FactoryTalk View for the HMI and either RSLinx 5000 or Studio 5000 for the PLC programming environment. Let's assume that you have equipment and are following along with this video. Of course, you want to begin using the robot as soon as possible. First, it would be best if you read or at least scanned through the provided manuals. It may not be practical to spend time reading every page, but please open the PDFs and spend 5 minutes looking through the manuals to understand the layout and what information is available for the future reference. Also, there are MLX200 training classes available through the Yaskawa Academy. This will teach you how to program in the MLX environment. This presentation will supplement that training class. Now, let's talk about the hardware. First, unpack the robot and control panel. It is necessary to mount the robot to the floor or another secure platform using appropriate fasteners for the mass of the robot. Once the robot is mounted, the yellow shipping brackets should be removed. The provided servo control panel should also be mounted in an appropriate enclosure to meet electrical, safety, and environmental requirements for your application and location. A heat sink unit has also been provided. We recommend that this is attached outside of the control enclosure. Section 4 of the MLX200 Hardware Installation Manual has a fuse chart which provides recommendations for each MLX200 robot. Once the robot and electrical panel are secure, it is appropriate to connect the cables. First, connect the robot's manipulator cables. These are called 1BC and 2BC cables, and they connect to the X81 and X82 pigtails. Next, the cable to the heatsink unit should be connected. Finally, an Ethernet cable between the PLC and MLX200 control unit should be attached. This can be connected to the Ethernet switch provided on the MLX200 sub-panel. One last note before we move on. If you plan to integrate a mobile view teach pendant, please do this later. It is best to verify that the provided hardware works as received from Yaskawa before doing further integration. Please also wait to integrate additional safety devices like e-stop buttons or safety gate switches until we complete this verification. MLX200 files have been developed using older versions of Rockwell software, which allows for a broad range of compatibility, both with PLC hardware and software. Before moving on, make sure your PC has the following software versions available: RSLinx 5000 or Studio 5000, version 20.04 or newer. Also, RSLinx Classic, any current version is fine, and FactoryTalk View Studio version 6.1 or newer. Let's also verify that your PC can communicate with the MLX200 control module. The MLX200 control module is Yaskawa terminology for the blue PC which controls the MLX200 motion system. The default address of the MLX200 control module is 192.168.1.200. Connect a cable between your PC and the Ethernet switch provided on the MLX200 panel. Next, verify that your PC can ping the MLX200 control module. If this is not successful, make appropriate changes to your PC's network settings and verify the power on status of the MLX200 hardware. The MLX200 control module network address can be changed later. For the purpose of verifying equipment and initial functionality, we recommend that this is not changed until the robot is verified and moved under servo control. Changing the IP address will not be covered in this presentation, but additional information can be found in the manuals. Every MLX200 robot system is shipped with a CD that includes 2 HMI files for factory talk view. These are files with an APA extension. There will be 2 files, one for a PC or panel view usage, and a second file for mobile view. Always use the file with PC in the file name when controlling the MLX200 robot from a PC or a laptop. Additionally, a ladder file must also be used. If this is your first MLX200 purchase, then a CD with the MLX200 Development Environment, or MLXD, should have been ordered and provided. This CD will include the ACD file for RSLinx 5000 or Studio 5000. Select the file which matches the type of PLC you have, either Compact Logix or Control Logix. It is important that the versions of both files match the runtime or firmware version that is installed on the MLX200 control module. Later on, an error will occur if a version mismatch occurs. Information on that situation will be discussed further in this MindFlash session. Now, open the RSLinx Classic program and configure the drivers to add the Ethernet IP driver. This step should be familiar to advanced PLC users and may already be configured on the PC. Now we will download the ladder or ACD file to the PLC. Open the file in RSLinx 5000 or Studio 5000. Put the PLC into remote mode. This may require the key switch. Go online and download the project to the PLC. Some dialogues may prompt you to change the CPU type or update the CPU firmware. Please make the best decisions based on your PLC configuration. When complete, put the PLC back into run mode. Finally, we want to confirm that the PLC and MLX200 control module are communicating. Wait a few seconds after download, and the green I/O light shown in the screenshot should become steady. This indicates that Ethernet communication is functional to the MLX200 control module. If this does not occur, some troubleshooting may be required. Next, we will begin to configure the HMI for factory talk view. Double-click on the APA file, extract it, and give it an appropriate name in the application manager. In this case, we named it MLX200. After the extraction process is complete, the dialog will disappear. Now start Factory Talk Studio from the Start menu on its own. Select View Machine Edition, pick application named MLX200, and open it. If your version of FactoryTalk View Studio is newer than 6.1, the software should prompt you to convert the project to a new version. Allow this to happen. Next, we will set up user permissions. From the Explorer tree on the left, double-click on Runtime Security. After the window appears, click the Add button. Now, we will define the new user to add. Change the option dialog to Show New Users Only. At this time, a button named Create New becomes available. Press it. A menu will appear on the slide. Select the option User. A new user entry dialog will appear. Enter Expert in the 3 fields. These fields are username, password, and confirm. Press OK to create the user. Additional user definitions and access levels can be found in the provided software manual. See section 3.4.4 for more details and information. The user expert should now display in the user list. Select Expert and press OK. The username should now be entered in the accounts list. By default, any user added to this list is added with full permissions. For the expert user, nothing needs to be changed. If additional user levels are added, then further edits would be required at this page, and those settings are also covered in the manual. Close this sub-window and select Yes when prompted to save changes to the document. Next, FactoryTalk View communication to the PLC needs to be configured. Under the Explorer window, find RSLinx Enterprises and expand it. Then double-click on the item Communication Setup. If the device shortcut AX is not defined, add it. Select the device shortcut AX before moving to the next step. Maximize all the main programs and sub-windows, otherwise some details may be hidden in the next slide. We will work in the window in the upper right-hand quadrant of the screen. This defaults to the Design or Local view. Find the PLC processor by browsing, then press OK at the bottom right corner when complete. Please confirm that the processor name found in the communication settings matches the controller name in RSLinx 5000. If the name in the communication settings does not match, it can be manually edited by right-clicking on the processor and changing the text properties. We have noticed that sometimes the text value in FactoryTalk View does not update if the PLC was recently programmed with a new project. This disconnection will lead to communication failures. Next, press Yes when prompted to change the AX shortcut. At this point, all the project settings should now be adjusted for testing the HMI solution. To start the HMI on your PC in test mode, press the icon in the menu bar that looks like a person running. After pressing the button, a processing bar will indicate compilation progress. The HMI can be run in this mode for 2 hours. Alternatively, a standalone HMI file, commonly called an MER, can be created, but that process is not covered in this presentation. The screenshots on this page show 2 examples of the HMI. The first example on the left shows the HMI not communicating successfully. In this case, the buttons show up with shadows or outlines. Troubleshooting will need to be done to remedy this situation. Something is not communicating properly or set up correct. The example on the right shows the HMI communicating successfully. This is the desired view. If you are moving on to this part of the presentation, it is assumed that the HMI is communicating with the PLC successfully. Now we need to test the user login. This will verify that the user profile created earlier is working as expected. Press the login button at the bottom of the screen. The user is expert, all lowercase. The password is expert, all lowercase. Then press the return button on the screen. After a successful login, the username, in this case expert, will be displayed on the bottom of the screen. It is also important to understand the two status indicators on this screen. In the upper left corner, there are two indicators which must be green in order to use the MLX200 controls successfully. The MLX control module connected and MLX module initialized. If both are not green, then there is a communication, power, alarm, or version issue. Additional troubleshooting would be required. Finally, we will verify the interaction of the hardware switches. This step can and should be revisited after connecting additional safety devices or a mobile view. Go to the menu and press the HW status button. The HW status button brings up the hardware status signals subscreen. This screen is a good way to diagnose the electrical functionality of various devices, either provided by Yaskawa or wired in later by you. The condition of each signal is described on this screen. Please review it before moving on. Contact Yaskawa customer service for assistance or copies of the electrical prints of your panel, which would be helpful to assist with troubleshooting any of these wiring errors. Additional information on wiring the safety devices can be found in the manuals. Let's take a moment to talk about MLX200 software versions. MLX200R and MLX200D versions must match. In this case, MLX200R is the firmware version that resides on the MLX200 control module, or the Blue PC. MLX200D is the software version of the ladder file, or the development environment. When the versions do not match, data transfer between the robot and the PLC ladder may not occur appropriately. This is due to the data structure changes or other software interactions which no longer match. When these versions mismatch, an alarm will be displayed and the robot will not servo on. Additionally, the version numbers can be checked by going online with the PLC and checking the controller tags window as shown on the right side of this slide. Let's have a quick discussion on how or why the version mismatch may have occurred. Some customers have purchased multiple MLX200 robots over several years of time. If the original MLX200D files are deployed into the PLC with a new MLX200 robot shipment, this would very likely result in a version mismatch. In other cases, a customer may have requested the software version to be shipped early. This allows the customer to begin the ladder logic development prior to receiving the robot. When the robot arrives later, it is possible that the MLX runtime firmware on the robot is newer than the MLX development or ladder version. The resolution to these issues is simple. Contact customer service and explain that you have an older version of MLX200D and now require a different version. They will be able to supply you with the appropriate files to match your MLX robot's runtime version. Let's have a quick discussion on why the alarm last enabled position validation error occurs. This happens when the last enabled position, which is saved in the PLC, does not match the current position of the robot at servo on. This condition results in an alarm and is intended to cause the operator to examine the robot for any physical changes. This situation can be caused by several scenarios. First, newly downloaded PLC program. This should happen on most new PLC and MLX initial startups. Second, improper shutdown of the MLX-R runtime or operating system. Third, movement of the robot with servo power removed. Fourth, e-stop of the robot during a high-speed motion. Finally, all alarm text will be displayed in a black bar at the bottom center of various HMI screens. An example is shown on this screen. If you double-click on the alarm text, it will bring up a full screen of alarm info, which will help you diagnose and troubleshoot the alarm. Now let's resolve a last enabled position validation error. First, go to the main screen. To do this, press the menu button and then the main screen key. Press the button, verify hardware position. This is shown on the slide. A sub-window will appear. Press the accept position button. Close the window after pressing the button. Finally, return to this teach screen. Now let's try to servo on again. Press the reset button, then press the enable servos button, and the servo on indicator shall now be gray with text servo on. In some cases, the robot may be shipped or parked beyond its normal operating limits. Use the release limits button at the top of the teach screen. When this button is active, it will flash red and display limits released in capital letters. Now try the first steps described in the slide again by pressing reset, enable servos, and servos should be enabled. Assuming the robot is clear to do so, let's try to jog the robot to home. Press and hold the button, jog to home, until the axes positions all read 0, 0. This will take longer than a DX200 controller and will slow down at the end as it approaches the target. Keep on pressing the button until it gets to 0, 0 on all axes. When the values are all 0, verify that the robot is lined up on its homing marks with the servos off. It is now appropriate to start working with the robot. We suggest that you are familiar with ladder logic and the MLX200 programming environment before moving forward with this part of the project. If this is your first time with MLX200, we recommend that you start with these videos at unifiedrobotcontrol.com and also keep the user manuals nearby as a reference. All videos can be watched in under an hour and will greatly enhance your understanding of how to sequence AOIs and generate successful solutions within the MLX200 environment. You've reached the end of the presentation. I hope if you have operated your MLX200 hardware along with the presentation that it has been a successful and educational experience. If there is anything else that you would like to know, please send an email to the presenter or use the survey at the end to provide additional feedback or suggest things that can be improved in the future. Your feedback is appreciated, and thanks for watching.